In this example, we're going to solve for x in the following equation. Log base 5 of 4x minus 2 plus log base 5 of 2 is equivalent to log base 5 of 8. Now what we'd like to do is, over on the left-hand side, I notice that there is an addition of two log base 5s. So I'm going to use logarithm laws over on the left-hand side to combine this into a single logarithmic expression. Log base 5 of 4x minus 2 times 2. Remember that addition on the outside of our two logarithms is going to become multiplication inside of our single logarithm. Now let's distribute that 2 through the brackets just to simplify a little bit more. That's going to give us log base 5 of 8x minus 4. Next, in order to remove this log with base 5, we're going to take the exponential of base 5, and we have to apply that to both sides of our equation. So what we end up getting is 5 to the power of log base 5 of 8x minus 4 is equal to 5 to the power of log base 5 of 8. Since the action of taking the exponential with base 5 followed by the logarithm of base 5 are inverse operations, these two actions are going to undo each other. On the left-hand side, we're going to be left with 8x minus 4, and on the right-hand side, a similar thing happens, and we're going to be left with just 8. Adding 4 to both sides gives us 8x is equal to 12, and dividing both sides by 8 gives us x is equal to 12 over 8, or if we simplify our fraction, 3 over 2. Recall that for logarithmic functions, the inside of that function has to be a positive number. So I need to take this 3 over 2 and substitute it back in up here to ensure that this log base 5 has an argument that's going to be positive. If we make that substitution, we're going to get 4 times 3 over 2, that's 6. 6 minus 2 gives us 4. So yes, this expression here is going to be defined. So we can accept this value of 3 over 2 as a valid solution to our original equation. Next, let's see how we can apply the methods of this section to find an inverse function for a logarithmic function. Given this function, f is equal to the natural log of 2x minus 5 plus 6, how can we find the inverse function of f? Well, the first thing we would like to do in this case is replace f of x with y, and then we're going to interchange the place of x and y so that we have x is equal to the natural log of 2y minus 5 plus 6. And now our goal is to try to isolate y. If we can isolate y, then we've found the inverse function of f. We can first subtract 6 from both sides. That gives us x minus 6 is the natural log of 2y minus 5. Now we need to get at this 2y minus 5. In other words, we need to undo this natural logarithmic expression. In order to do that, we can apply the natural exponential function to both sides. That's going to give us e to the x minus 6 is equal to e to the natural log of 2y minus 5. And since the natural log and the natural exponential are inverses of each other, these two actions are going to undo each other. And on the right-hand side, I'm going to be left with 2y minus 5. Adding 5 to both sides, we get the natural exponential to the power x minus 6 plus 5 is equal to 2y. And then finally, dividing both sides by 2 gives us e to the x minus 6 plus 5 all over 2 is equal to y. Therefore, we can conclude that our inverse function is equivalent to e to the x minus 6 plus 5 all over 2.